This is the work energy standard, and in this problem we have Justin, who is traveling down Lake Avenue at 32.8 meters per second in his 1,510 kilogram Camaro. So there's a police car, so he has to quickly slow down to the legal speed of 20.1 meters per second. We have to find the initial kinetic energy, the kinetic energy after he slows down, and the total amount of work done on the Camaro during the deacceleration. So first, we have to find the initial kinetic energy, which is going to equal 1/2 mv squared. So they give us his mass and his velocity, initial velocity, and that comes out to be 812,259.2 joules. Then we have to use the same equation to find his kinetic energy after slowing down. So after plugging in the same numbers and switching the velocity to the legal speed limit, we get 15,175.5 joules. Now, to find the total work, we have to realize that work is going to be a change in the kinetic energy. So work is going to equal delta E. We also know that delta E is going to equal the equation for the kinetic energy final minus the kinetic energy initial. And that we already found those, so we take 15,175.5 joules and subtract that from the initial kinetic energy, 812,259.2 joules, to get a negative work energy of negative 797,083.7 joules.